I want to go over what we call the constant acceleration equations. I'm going to derive them with you. I am not, Mandy, I am not going to ask you to rederive them from scratch. But I am enough of a nerd that I try and show you where stuff comes from. Okay? But they are all on your green sheet. First of all, by definition of constant acceleration, acceleration is the velocity change per second. Acceleration is your change in velocity. It's how fast you change your velocity. It's the meters per second change per second, which is why it was meters per second squared. Total velocity change is found by multiplying acceleration and total time. What? Means this. Acceleration times time equals change in velocity. Change in anything is final minus initial. You can write that down. You won't bother memorizing that. Rearranging this, traditionally we get the V final by itself. How would I get the V final by itself? It's a good question. Mackenzie, can you see it sitting there on the right-hand side? I'll put a red dot above it for a while. Eventually I'm going to stop putting the red dot above things, but just to target it. See it there, see it there, see it there, see it there? Yeah. What's on the other side? That side. And you can just say AT. From now on, if you say two letters side by side, we'll know that you meant times, and we'll tend to abbreviate. So what's on the other side? The AT. Okay? It would just drop down like a domino. So rearranging this gives us, I'll drop the AT down like a domino. I'm trying to get the VF by itself. Ethan, what else is on the same side as the VF? A minus VI. What's the opposite of minus VI? By the way, what we're going to be doing is we're going to be doing our equation solving rules, the thing that you learned in Math 8 and 9, where if you had a plus 5, you would minus 5 from both sides. If you were times by 2, you would divide by 2. We're going to do the opposite mathematical operation, but with letters. So what's the opposite of minusing VI? Don't overcomplicate it. Yep. Plus VI. Why'd you put the VI in front? Because that's where it appears on your formula sheet. You could have said AT plus VI. Ibrahim, what's 5 plus 3 in your head? What's 3 plus 5 in your head? When you're adding two things together, does the order that you do it make a difference, or did you get the same? Okay, so we're going to write VI plus AT. Don't write this down. Look up. And then you could, don't write this down. You could, Hannah, write that, but you'll notice on your formula sheet, the VF is written in the front. This is our first kinematics equation. We're going to put it in the box here. Final velocity equals initial velocity plus acceleration times time. Where acceleration times time is your velocity change. Dom, how many different terms do you see there? I'm ignoring the I and the one VF, one VI, one A, one T. How many equations is that really hidden for? We'll learn to rewrite them rather than memorize all 4. Okay. What if you're not dealing with velocity? What if you're dealing with speeds? This still works for non-vectors. This still works as a scalar equation. If it says find the final speed, it's going to be the initial speed times the magnitude of the acceleration. Who cares about direction times time? Times a scalar. So we also want to find some equations with distance or displacement in them. On the little lab that you did where you simulated distracted driving, we use D equals VT. The problem with that is in real life you speed up and slow down, and I didn't let you do that on that lab. You had to stay at a constant speed. I couldn't yet give you an equation that had an acceleration in it. Now we can. First of all, we said that average velocity is equal to distance over time. I want to get the displacement over time. I want to get the displacement by itself. See the displacement there, Goggins? See the D, see the D, see the D? What else is on the same side as the D? On the same side as the D. A T. What's the T doing to the D? Adding, subtracting, multiplying, or dividing. If I wanted to move the t over, what's the opposite of dividing by t on the right-hand side? It's the same as by t on the left-hand side. And Ethan, that's what we were getting at earlier as well. You look kind of puzzled. That's all we're going to be doing. We're going to say doing the same thing on one side is the same as doing the opposite on the other side. So I can rewrite this as displacement equals average velocity times time. The average times time. Vt. Oh, and I'm going to do one more thing. I'm going to write an expression for average. So ready? We do a little thought experiment. Hannah, you ready, my angel? If I have $10 and you have $20, what do we average between us? 15. How can you take the number 10 and the number 20 and get 15 as an answer? Add them up and divide by. So you ready? We're also going to say this. The average is add them up and divide by 2. I think, yeah, I have that second line right there. With me so far? With me so far? With me so far? Maddie, what's the average the same as? I'm going to say it again. I'm going to ask you to repeat this, not to make fun of you, to make a point. What's the average the same as? Wherever I see a V average, what can I write instead? What can I replace this V average up here with? So here's your second equation. Distance equals VF plus VI divided by 2, and that's going to be in brackets times T. Thanks. Second equation there. Okay. By the way, really where you have to put the brackets if you're using your calculator, right there. Anytime you have a fraction that has more than one thing on the top, you better put it in brackets. That is your second equation, yes? Oh, and this is a vector equation. It will work for displacement, velocity, and velocity. It will also work as a scalar equation if they ask for a distance and they give you a speed and a speed. Works. Again, let me emphasize, Dom, you don't need to know where this equation comes from, but you do need to know that it's on your sheet. Second one over. Okay. A little note. This assumes uniform or unchanging acceleration. You're pressing on the gas or you're hitting the brake, but you're not changing how hard you press the gas. You're not changing how hard you hit the brake. That we can't deal with right now. That you really do need calculus. So that's why I wrote, if you have changing acceleration, it gets ugly. You need calculus. So, if we have uniform acceleration, we can find average speed by VF plus VI over 2. Hannah's theorem. She came up with that. We could name it after her if we wanted to. Okay. By the way, the proper symbol for average is this. That's the symbol for average. The problem is when I type these things and shrink them down, it's really tough to tell the difference between the vector arrow and a horizontal line. So even though that's correct for average, and I included it right there, I will almost always just put a subscript of average so it stands out, okay? Technically wrong. A physics prof would glare at me, and I would say, yeah, I'm shrinking stuff down and saving paper, and pick a better symbol next time. Okay. Distance or displacement is average. Well, distance is average speed times time. Turn the page. Displacement is average velocity times time. So we can write this. This is the equation that we used on our distracted driving activity. The only reason, Lorenzo, that I didn't bother putting average on the distracted driving activity is I wasn't letting you speed up or slow down, so your average speed was your speed because it was the same the whole way through. With me so far? Ready, Lorenzo? No. Ready, Maddie? What's V average the same as? Wherever I see a V average, what can I write instead? Okay. So I can write it like this. That's the one that we had in the box on the previous page. But Ibrahim, there's another way to write VF. The first equation in the box, and I put it right here. Can you read that to me, Ibrahim, my friend? VF equals? What's VF the same as? Same thing. Wherever I see a VF, what can I write instead? I'm going to put that VI plus AT right there. Okay? The D is going to drop down like a domino. What am I going to write instead of VF? Okay, so there's going to be it's going to be a big, long, massive fraction. And that VF is going to be a VI plus AT, and then there's still a plus VI that drops down like a domino. All over 2. And then times T. Pause for a moment and see if you can follow my reasoning. And again, let me emphasize, Damien, I'm not going to ask you to reproduce this on a test, but I'm enough of a nerd, I want to show you where it comes from. So, I replaced this VF from an equation that we already derived, with VI plus AT from another equation I already derived, and I got that. In brackets it says VI plus AT plus VI. Hey, I have a VI plus VI. Those are like terms. They are. What's 1 VI plus 1 VI? So another way to write this, do a little math here to get 2 VIs plus AT all times T over 2. Yeah. Shh. Patience. We're heading to a goal here. I'm now going to do this, actually, Faith. Boom. Boom. I'm going to multiply the T onto everything. So I'm going to draw a little arrow, new equation, and I get D equals, there's a 2 VIT plus ATT. Although, what's a shorter way to write ATT? What's a better way to write T times T? T what? And this is all over 2. Some of you may have noticed we're heading towards that third equation on your formula sheet. We're heading there. Morgan, is this a big fraction? Say yes. Is everything being divided by 2? Then you can rewrite this as 2 VI over 2 plus AT squared over 2. Since everything is being divided by 2, you can break that top fraction up and put each chunk over 2. Now, why did I do that? Look. What's 2 divided by 2? They cancel. And I get the third big kinematics equation. It looks like this. D equals VIT, because the 2 canceled, plus, instead of writing AT squared over 2, instead of dividing by 2 is the same as multiplying by what? If you're not sure, look at your green sheet and figure it out. Dividing by 2 is the same as multiplying by what? What? This is the scalar version. Distance equals initial speed times time plus 0.5, a half, times the acceleration times time squared. Use your x squared button on your calculator. If you want the vector version, displacement, velocity, Acceleration still works. That's the third equation. There's a fourth one, and I'm not going to derive it today. I'm just going to give it to you. What's the fourth one in that row? Dom, what is it? So we're on the green sheet, third row down, fourth one over. It's the one that's got the squared in it. Got it? VF squared equals? Yeah, that one. VI squared equals? VI squared? 2AD. These are the four kinematics equations that we're going to be using. There really aren't more. In fact, one of these you'll find out next year is redundant. Each of them contains four variables, so each of them contains four different equations. So technically this is 16 different equations. And if you want to, you can memorize them all. Not the way to go. I'll teach you how to derive them in your head. So on the next page, these are the four uniform acceleration equations. There's two different ways to write these. I will use a little I for initial and an F for final. But if you're ever looking at a British handout, instead of initial, they use a 0. In fact, they'll say it V naught, because 0 is not in England. Okay? So you might see it written this way, V naught plus VF. V naught T. I'll use VI and VF all year long, but I can't guarantee that every handout that I grab from the internet or every graphic that you come across won't use an I and an F. It might use an I and nothing. So, okay, so far, these are the four equations, and from this, we can generate more. We're going to start out today with numbers only, and then we're going to move into quote-unquote word problems next lesson. I use an approach that I call DFIC. I've alluded to this before. Until you get good, I strongly encourage you to use this approach. The letter D stands for list your data. What do I mean by that, Chantel? I've done the listing of the data in example 1. If you gave me a word problem, I would say, what are they asking me to find? I would write down a question mark next to that. Then I would list everything else, looking at units, looking at physics words. That's the listing of the data. In fact, you'll notice in every example today, I've done the listing of the data for you. Next lesson, we'll pull it out of the word problems themselves. The F stands for find a formula. The I stands for insert the numbers, and the C stands for get your calculator. Or if you're feeling nerdy, try and do it in your head. If you do this, this is not the end-all, be-all. This is not the best way. Eli, you alive? Not. Wake up. Yeah. Be alert, my friend. This is not the end-all, be-all, best way to learn physics, but this is a good, handy-dandy, something I have in my tool belt so that if something goes wrong, if I don't know what to do, I will be okay. So, let's walk through it together. Example 1. What are they asking me to find, Justin, my friend, in example 1? So I'm looking for an equation that has time in it, but I'm also looking for an equation that has a VF, a VI, and an A. Now, actually, what I do is I notice which letter I don't have. Which letter don't I have? D. Don't pick anything with a D in it. So from that third line down, give me the only equation that has a VF, a VI, an A, and a T in it. There is only one from your green sheet from the third line. Look at your green sheet. Don't look at the white piece of paper. Get your eyes used to looking at the green sheet. What's the only equation that'll work here? Justin, my friend, can you read it to me? Yep. Everybody write that down. So far, so good? Justin, what did you say I'm trying to find? Time. So, until you get good, put a little dot above the time. I'll put a little red dot there. I want to get the t by itself. Now, some of you right now may be saying, Mr. Dewick, why can't I just stick in numbers? Please resist sticking in numbers. Instead, I'm going to teach you to do the algebra. It'll work much better. How am I going to get the t by itself? What side, Justin, is the t on? The left side or the right side? So the left side is going to drop down like a domino. Anything on the left, kathung, just drops down. And I always do that first, and I always put the equal sign because it gives me kind of a frame of reference. Actually, I probably shouldn't write the equal sign. I take that back. I always drop the VF down. See the T, 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 Justin? Yes, 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 yes. What's right next to the T? What's the A doing to the T? How will we move the A over? Divide, but the rule for this is you do reverse BEDMAS. You're going to do your multiplying and dividing last. We're going to deal with the VI first. What's the VI doing to the T? So how do we move it over? So the VF drop down. There's a minus VI. Drop your equal sign down, and then don't write this next bit down. Instead, just imagine it. I'm going to write this down, but I want you to see if you can imagine it. The AT would just drop down, but I'm just imagining it there. Justin, what are we trying to get by itself?
T.
What's right next to the T still? A. How will I move the A over?
Divide.
You know what? Write that down. There is another equation, but I'm going to teach you how you can derive it. And you're going to find in about a week and a half, you'll glance at it and you'll have the equation in your head. And if you get there, that's my goal for all of you. We've found a formula. Now we're going to insert numbers. T equals, Justin, my friend, what is VF? Read it right from the data that's listed.
29.
And this is why I like this method. If you've listed the data, now it becomes fairly plug and chug. 29.6, you say? Minus, what's VI?
3.2.
Divided by, what's A?
2.9.
Now, if this was a word problem, here's what it would have said. Suppose you're traveling at 3.2 meters per second. How long would it take you to reach a final speed of 29.6 meters per second if you were accelerating at 2.9 meters per second squared? That's what the question would say. Justin, this is a fraction. Yeah? Is there more than one thing on the top?
Yes.
I have to put the top in brackets. So all of you with your calculator, I strongly, strongly, strongly encourage you, follow along with me on your calculators, because this is where you're going to get your practice making your dumb mistakes and learning how your calculator works. So I go bracket 29.6 minus 3.2. Justin, I close the bracket off. Okay? What does a fraction mean? What mathematical operation is that? Divided by. Is there more than one thing on the bottom, Justin?
No.
Do I need brackets on the bottom? Eli, leave the hoodie off. Thank you. Just stay awake. And I get 9.1, that. By the way, looking at the data that they gave me, how many sig figs is the 29.6? Maddie? 3. How many sig figs is the 3.2? How many sig figs is the A? How many sig figs should we go to technically then? 2? Okay. So 9.1? Last thing, and I'll leave you alone, Justin. Units. What do I measure time in? And this is why it's worth memorizing what units go with what, because it becomes almost a no-brainer. But the habit you want to get in anytime you're doing your final answer, units. That's the only thing I'm going to be fussy on, units on your final answer. Let's do another one. Example 2. Example 2. I've done the listing of the data for us. Aisha, what are they asking me to find in example 2?
D.
So I'm looking for an equation. Has to have a D in it. And I also notice there's a VI, an A, and a T. What equation will I use from that green sheet? Look at your green sheet. Third row on your green sheet. Do I have VF?
No.
So why would I read that? Okay. By the way, what I did is I said, I don't have a VF. I'm not going to read anything with a VF. There's only one equation that has those 4 in it. So keep going. Try a different one.
D equals VI T
Oh, I like that. Yes?
plus 1/2 AT squared.
Okay. What are we trying to get by itself? What are we trying to find? Conveniently, the d is already by itself. That'll happen sometimes too. So this one, I don't even have to rearrange, but I do want to practice typing it into my calculator. So now let's plug in the numbers. VI, negative 1.5. I guess we started out going backwards. T, 12, plus 0.5. A is 4.5. 12 squared. Everybody look up for a second before you go to your calculator. Aisha, that is how I would handwrite it, because when I handwrite things, because I don't have a limited small display, brackets make things easier. I would never type it that way. When two brackets are side by side, what mathematical operation is that really? So here's, and this is how I'm going to be fussy. I'm going to strongly encourage you to type it. Get your calculators out. Here's how we're going to type this. Negative button 1.5. Oh, Justin, is there a fraction here? So you know. There was a 1/2, but what's 1/2 as a decimal? So I'm going to assume you guys are okay with that. So is there a fraction here? No. So no need for brackets around everything on the top. Okay. I type negative 1.5. I hit times and I hit 12. I don't go bracket, bracket, close bracket, bracket, bracket. I hit plus 0.5 times 4.5 times 12, and I hit my x squared button. I think that looks far clearer than going bracket, negative 1.5, close bracket, bracket, 1, 2, close bracket, plus 0.5, bracket, 4.5, close bracket, bracket, 12. I think that top line is easier to follow, is it not? I'm going to argue, way easier, I think. Okay? So this is one of the times I discourage you from using the brackets. Now, if you have the POS calculator, that'll be helpful, because yours doesn't show brackets worth a darn. Sorry, Brady. Do you get 306? Oops, I typed this one wrong. What did I do here, Mr. Duick? Oh, 0.05 instead of 5. That was silly of me. There's the 306, yeah. So no matter what, 306. Aisha, units. Yep. Yep. Do another one. Mandy, what are they asking me to find in example 3? VI. So I'm looking for an equation that has a VI, an A, a T, and a D in it. Basically, don't give me an equation with a VF, because they didn't give me that. I have no idea what you said. Sorry, what? Yep. Same equation we just did. Same equation we just did. Except, what am I trying to find here, Mandy? All right, all of us, let's put a big dot above the VI. There. Mandy, what side is the VI on? The left side or the right side? Right. The other left. Yeah, the right. So the left side just drops down like a domino, so I'm going to drop that big D down. On the right side, right next to the VI, what's happening? And it's multiplying. Do that last. There's also plus AT squared. How would I move a plus a half AT squared? How would I move a plus a half AT squared over? What's the opposite of plus a half AT squared? Minus a half AT squared. Now, I'm also going to go, so I'm going to go minus, I'm going to change the 1/2 to a 0.5, because that's what I'm going to type on my calculator. AT squared equals, don't write this next bit down. I'm going to, just so you can see it, but you're just going to imagine it. The VIT would drop down. This is another way to write that equation. Don't write that down, though, because what are we trying to get by itself? How would I get that T over then? What's the T doing to the VI? Adding, subtracting, multiplying, or dividing? How I move it over? You don't say. So we can write this one down. That is yet another equation. Don't memorize it. I'll teach you how to derive all of these. And now we are at the plug and chug stage. Mandy, is there a fraction this time? Say yes. So I'm going to have to use brackets and things. What's D in this case? What's D? No. Read. It's in the list of stuff there. It's on your sheet, kiddo. You're all squinting up there. I think I gave it to you. D. What's D? D. Negative 40? Yes? What does that mean? It means we started out 40 meters behind the start line. We started out 40 meters back there. Okay? Take away 0.5. Mandy, what's A? Negative. We're accelerating backwards. So we started out behind us and we're accelerating backwards. You okay with that? T. What's T? Squared. All divided by 24. I'm learning if I hold the tablet in my hand and I write, you can see as a lefty, I tend to slant up, don't I? What I need to do, I guess, is spin the tablet just slightly at an angle, and now I'll write straight, apparently. Will that work? No, I want to spin the tablet this way at an angle, I think. Mandy, is this a fraction? Is there more than one thing on the top? Big bracket. Boom. Negative 40. Not minus sign 40, but negative 40. Don't hit subtraction 40. That's subtraction. Now you'll notice on most calculators, a negative and a subtraction sign look different. They do on mine. Can't use them interchangeably. 0.5 times negative 3.5. I'm not going to put brackets. Times 24 squared. Close off the top. Divided by 24. And you get 40.33. By the way, as a word problem, here's what this would say. How fast would you have to start out traveling at if you wanted to accelerate backwards at 3.5 meters per second squared for 24 seconds and end up 40 meters behind from where you started? That would be the word problem. We calculate, apparently 40.3 seconds. Oh, how many sig figs should I technically go to here? Two. I'm going to go to 3 sig figs because I want the decimals. So I'm going to go 40. Hello. Why is everything vanishing there? Oh, that was a little strange. I'm going to go 40.3 meters per second. Couple more, we're done. Couple more or one more? Can't remember. Couple more, we're done. Okay. Morgan, my joy, you ready? What are they asking me to find in example 4? Which equation am I going to use? I heard you start and then I couldn't hear you. I don't think I can use that one because you said T, did you not? Good. That's the key to doing these, is to recognize what you don't have. And I love the way you said it, Morgan. Oh, there's no T. And that's what it'll become. It'll become that obvious. So find me the equation that doesn't have a T in it. It's only one. VF squared. Good. What are we trying to get by itself, Morgan? Do I have the VF by itself? Well, almost. I don't have the VF by itself. I have the VF squared by itself. So here's the question. How would I get rid of a squared? What's the opposite of squaring something? What? I heard it. What? Holy smokes, Mr. Duick. Square root's actually useful? Oh, heck yeah. So I want to show that, but I don't want to write much. So you ready? Here's what I think I'll do. I'll change colors to make it stand out. I'll cross out the squared and put a big square root like that. I think that's enough, Colby, to show whoever's marking, hey, I clued in. How do you get rid of a squared? Square root. Yeah. Big square root. What's VI, Morgan, my joy?
4.5.
And don't forget there's a squared on it. Plus 2 times 9.8 times 126. Mr. Dewick, how do you type this into your calculator? Here's what I would not suggest. Now, if you have a newer calculator, show me yours, Maddie. No. No. Show me yours, Ethan. Yours might. When you hit the square root button, does it kind of do a little indentation and extend the square root thing over everything? Okay, so you can get away with doing this all in one fell swoop. For the rest of us that don't have that, when I have a big complicated square root, Morgan, which this is, here's my method. I actually don't do square root yet. I type what's inside the square root. I go 12.5 squared plus 2 times 9.8 times 126, and I hit equals. And then I go square root answer button. I've found I make far fewer mistakes that way. So 12.5 squared times 2 times 9.8 times 126. If you hit equals, you should get 2625.85. And then I go square root. And this is also where it's worth you finding your answer button. You all have one. You're going to use it a whole bunch this year. Find it. And I get 51.24304. That there. Is that right? Got me? Yeah? Anybody not able to find their answer button? This is your chance to ask. You do have one. Show me your screen. Oh boy, this POS might not. On yours, you type everything backwards, right? So I think what you're going to do is you're going to go 12.5 squared plus 2 times 9.8 times 126 equals square root button, and it should just change on your screen, I think. Or you can invest in a better calculator. I'm going to write down 51.2. It is 51.2, yes? More, yeah? Absolutely not. That's incorrect. The square root and that squared don't cancel. I'll prove to you why later. It's a great question, and I'm glad you asked that, but no. Very quickly, Morgan, we found V final. What are the units for velocity? Yep. Now, in the homework here, I'm putting the units next to the variable. As we get more advanced, I'll stop doing that, but it's worth memorizing what units go with what units. Aisha, you ready? Don't write this down, just watch. Put your pencils down, everybody. So what you're telling me is the square root of 3 squared plus 8 squared should work out to 11? That's what you're saying, because you're saying the squareds cancel. But wait a minute, isn't this also 9 plus 64? Isn't this also the square root of 73, which ain't 11? I'll tell you that right now. So which one is right? That second method. The square root actually contains an invisible bracket like that. When you have multiple things inside of a square root, there's an implied bracket. And so you do what's inside the square root first, as is, not canceling anything, get an answer, then you square root. Have I convinced you? It's a great question. I'm glad you asked. I thought that was a pretty good explanation. No, what? No, huh? Hey, no? Okay. Fine. I think 2 more, we're done. Is that right, Mr. Dewick? Woohoo! Let's kick it up a notch. Let's bring the thunder. Evan, you feeling lucky?
Sure.
Okay. Evan, my friend, what are they asking me to find in example 5?
Acceleration.
What equation?
Dx squared equals vi squared plus 2ab.
Okay, you all folks okay with how we got that? Did you find the correct equation, or did you notice they didn't give you t and just read the one that didn't have a t? Either way is fine.
I just noticed they didn't have a t.
Yep. Also, you're going to notice, and I emphasize this more in Physics 12, Faith can attest to that. Basically, the rule is if you know three things, you can find the fourth, but you need three to find the fourth. So the three I know here are V initial, distance, and V final. Sorry, V initial, acceleration, and V final. Evan, what's this question asking me to find?
Acceleration.
I'll put a big red dot above the A. See it, see it, see it, see it, see it? Dom, you okay with me? Good yawn? You back? Evan, what's going to drop down like a domino?
VI squared.
Boom. There's a plus VI squared, and there's a times 2D on the A. Reverse bed mass. What are we going to do first?
Minus the VI squared.
So it's going to be a minus VI squared. And then what's left behind, don't write this down, just imagine it. What's left behind on this side is that right there. What am I trying to get by itself?
A.
What's the 2 and the D doing to the A?
Times it.
How do I move them over?
Divide.
So another way to rewrite this equation would be to have a 2 and a D there. That's how you can calculate acceleration. Don't memorize that. I'm going to teach you how to derive it. Let's carefully plug in numbers. V final, 12 minus V initial, 20 divided by 2 times 86. By the way, Evan, what was my final speed here?
20,
No, just read it. Huh?
12.
12. What's my initial speed?
12 squared.
What's my initial speed?
Initial 20 squared.
By the way, I forgot the squareds. You're right. That's terrible of me. But let me get back to my. Thank you. I owe you candy. Evan, looking at the data they gave me, what's my final speed? 12. What's my initial speed?
20 squared.
No, it's not just from the data that they gave me. It's not the equation. It's squared. But look at this right here. This. What's my initial speed? 20.
20.
What's my final speed?
12.
Am I speeding up or slowing down?
Slowing down.
Am I expecting a negative acceleration or a positive acceleration here? If I get a negative here, I'm not going to freak out. I'm going to smile and say, I expected it. So one of the other things I'm going to teach you, Hannah, is glance at your data and have an idea ahead of time what the answer should look like. Evan, my friend, this is a fraction.
Yeah.
Is there more than one thing on the top? So there's going to be a great big bracket around the top. Bracket, 12 squared button, take away 20 squared button, close off the top. Divided by. Is there more than one thing on the bottom?
Yeah.
Bracket around the bottom. 2 times 86, close off the bracket. And I get a negative acceleration of negative 1.4883. You know what? I'll call it negative 1.5. I'll go to 2 sig figs here. Mr. Dewick, how many sig figs do you want us to go to? Go to 2 or 3 and you'll be good. But only round off at the end. During the question, don't round off. If you use something to find something, keep more sig figs than you need. Last one. Toughest one. I'll do this one, but we'll talk ourselves through it. You ready, Gio? What are they asking me to find? Time. They gave me VI, they gave me A, they gave me D. Which equation? That part I'll ask you all to figure out. Which equation? This equation we're going to use an awful lot. Specifically, we're going to use it an awful lot in a very specific situation. Mandy, what's VI? What's VI? 0. Yeah, 0.0. I just did that for sig figs, but what's VI? 0. Hannah, what's VI? Mandy, what's 0 times 5? What's 0 times 10? What's 0 times a billion? Here's the punchline. Are you ready? What's 0 times t. Loud and proud, girl. Because vi is 0 in this particular situation, that whole thing vanishes. And we get yet another modified special subcase of our equation. Looks like this. D equals at squared over 2. Mr. Dewick, you wrote over 2. Well, yeah, the 1/2 in front is the same as dividing by 2, but that looks prettier. You okay with that, Justin? All right. Hey, folks, what are we trying to get by itself? The t. What's right next to the t in front? Okay, see it? What's the a doing to the t? Adding, subtracting, multiplying, or dividing? Multiplying. How will I move it over? So everybody right now, if you want to, this is how much work I would expect you to show. You can cross out the a and put it down there, because the d would drop down like a domino and stay there. Maddie, what's the 2 doing to that t?
The bottom one?
Yeah, the bottom one.
Dividing.
How will I move it over?
No.
So cross out that 2, do that. And so our new equation is t squared equals 2d over a. It's really 2d over a equals t squared, but I like to have the thing by itself on the left, so I just flipped everything. T what?
Right.
Who remembers how to get rid of a squared? There's another equation. This is an equation that will help you find time when you start at rest. It's going to be the square root of 2 times 2,400 divided by 20. Is there more than one thing inside this square root? Ethan, you've got a better calculator because yours has a nicer interface, but for most of us, we'll go 2 times 2,400 divided by 20 equals, and then I'm going to go square root answer button. You're just going to hit the square root button on your cheap calculator, and I think, Brady, you will as well. So the reason I don't like those as well is because you're typing things backwards from the way we write them and say them. That irritates me. I don't go 9 square root. I say the square root of 9. And I get 15.491. That there? Let's call it. Oh, how many sig figs should I go to in this question, technically? How many sig figs in this first number? No. That's 3 sig figs, my angels. 3 sig figs, my angels. 5 sig figs, my angels. I'm going to go to 3 sig figs, 15.5. $15.5. This is what we're going to be practicing for a while. Yeah. Time, so it should be seconds, Mr. Dewick. Mandy gets a candy, so does Evan. I caught the same thing. As you said, wait, my finger was already on the screen scrolling up, but you beat me to it. I never make mistakes. Your homework is every question. Now, right now, there's like 7 minutes left, and that's a lot of homework to throw at you. I'm going to tell you right now, next lesson is going to take 2 classes. You're not going to have any homework next class. So you can divide the homework today, Thursday, with, when do I see you next? Tuesday. You can spread it out over that. Okay? You don't have to get it all done tonight if you don't want to. But your homework is every question. There are some yucky nasties. I haven't covered every possible equation. So there will be some that you'll ask me about next class. That's okay. I've set this up that way on purpose. Typically, you're going to find in the homework for the rest of the year from now on, I'll cover 90% of the homework in class, but I'll always leave about 10% of the homework to see who can figure it on their own and have that aha moment on their own. Otherwise, ask me in class or during a flex block. So you got 6 minutes. Try it. You can do number 1 and number 2. You can do these right on the page if you write small, or you can do these on a separate piece of paper. It's up to you.